Hello everybody. Today we'll be talking about section 2.3 and 2.4, which is going to be on absolute value and the ruler postulate. So this is still kind of like an introduction to geometry, so there's nothing too complex, hopefully. We'll go ahead and get started and let's see how it goes, okay? So first we're going to need to define a couple of things. Well, first we define this one thing first, which is absolute value, and you might have heard of it back from algebra class. So the absolute value, it is defined as the following. The absolute value of a number, denoted as absolute value of x, is the distance from that number to on the number line to 0. So for example, over here, you can see that I have a picture of a number line, and you can see where x is located on the number line. Could be on the left, could be on the right, it could be on 0 technically. And remember, this is a number that's on the number line, so there's a number that's assigned to it. So for example, it could be like, say, -10 or 5 or 2.7 or -1. Nonetheless, the way we write it is the ones below right here. So the absolute value of -10 is supposed to be equal to 10, according to what we learned. And then absolute value of 4 is equal to 4. Absolute value of -3.1 is 3.1. And 6/7, the absolute value of it is going to be 6.7. So those are assigned values that are on the number line, and supposedly when you find the absolute value, it's supposed to represent the distance to 0. So for example, if I put, like, say, 5 over here on the right hand side, you can see that the distance from 0 to 5 is supposed to be equal to 5. But if I go to the left hand side and do the same thing, let's say if I go to -2, the distance from -2 to 0 is then equal to 2. So the idea here is that the distance is always going to be positive, just to keep things simple. Because on the number line, it is kind of like, you can go left or right, but we just care about the total distance, so we'll just go ahead and keep everything positive. So we can define absolute value as the following if we were to look at it as a function or a way to write it a little bit better. So for all x in the real numbers, and keep in mind, remember, the symbol means for all, and then this means real numbers. So for all x that are real numbers, x is defined as, absolute value of x is defined as the following. So you can see here I have kind of like a two-piece equation. This is what we call a piecewise function. If x is positive, then we don't do anything. It's just plain old x. And that happens if x is greater than or equal to 0. So that's the top equation. But if x is negative, like, say, you have absolute value of -7 right there, then that means that this is going to be changed into the negative of that. So since absolute value of -7 is equal to 7, then one way of saying it is that, I'm going to go ahead and take the -7 and put another negative in front in order to give me the positive value that I actually need. So depending on what x is, if x is less than 0, then we take the negative of that number in order to make it positive. But whereas if x is positive, we'll just go ahead and keep it the same. And if it's 0, it's just 0. So here are some examples of algebra problems that you might have seen back in algebra days, just to kind of help you refresh the memory. So let's say that you want to solve for x, where absolute value of x is supposed to be equal to 20. So the way we kind of interpret this problem is that on the number line, what point or what points are going to be 20 distance away from 0? So then that means that you can kind of like see it over here visually. Here's 0. And I can either go 20 to the right, which would then give me 20 on the number line, or I can go 20 on the left and give me -20 on the number line. So there are two answers for this. So in essence, what that means is there are two values of x that would satisfy this equation. So x is equal to 20, or x is equal to -20. And I think you guys have kind of like, seen how this works with the absolute value. You can plug either one of those numbers in there, and the result is that when you take the absolute value, it'll become 20 then. Going into something a little bit more complex, let's say this time solve for a, where you have the equation absolute value of a plus 7 is equal to 3. Now this part is a little bit tricky because if you think about order of operation, the way it works is that you're supposed to subtract 7 from both sides, and you're going to end up with absolute value of a is equal to -4. And this, unfortunately, is impossible to solve for because if you remember, absolute value, the distance from 0 to that number, a in this case, is supposed to be positive or 0, non-negative basically. So we cannot actually solve for this. So the answer is the empty set in this case. Okay, so let me go ahead and box the answer above. Let me box the answer over here. Okay, let's go a little bit more advanced. This time we have solve for t inside this absolute value is equal to 21. So what I'm going to do is I'm going to go ahead and take the first problem over here, and you can see that a quick way of looking at how to solve for the answer or what's inside the absolute value is just say what's inside the absolute value is equal to the number, or what's inside in the absolute value is equal to the negative number. So in essence, what I'm going to do here is I can split into two equations. 2t plus 5 is equal to 21, meaning just as is without the absolute value. It's been going in a positive direction. Or we also have 2t plus 5 is equal to negative 21. So either one of these should be sufficient in order to solve for the equation. Well, now again, it's just a matter of algebra then. So we subtract 5 from both sides. So that would give us 2t is equal to 16. And if we divide by 2, then t is equal to 2. So that's one answer. Or on the other side, we have 2t is going to be equal to negative 26 because we subtract 5 from both sides. And so we get t is equal to negative 13, and that's going to be my other answer. So either t is equal to 2 or t is equal to negative 13. And if you remember back in the logic section, right, not too long ago, we actually cannot write it and say t is equal to 2 and t is equal to negative 13 because the word and means what they have in common. It's the intersection. So if you think about it as a transitive property, how can t equal to negative 13 and t equal to 2 at the same time? According to the transitive property, that's not possible. So that's why we use the word or in this case, to indicate that t can be one or the other. Okay. Now, here's the last example with the absolute value. Let's say this time we have this messy thing. If you want to give it a try, go ahead and do so first. But if not, then I'm going to go ahead and try to solve for this. Pause the video if you like and try it on your own. Okay, order of operations says, okay, let's go ahead and take care of the 2 first. We're going to go ahead and add 2 to both sides. So then that means now we have absolute value of 3u minus 1, and then with the 4 on the outside, that's equal to 20. Then we have absolute value of 3u minus 1 is equal to 5 because we divided by 4 from both sides. And then now we're going to go ahead and try to solve for u. So we'll split it into 2 parts just like we did before. So 3u minus 1 is equal to 5. Or we have 3u minus 1 is equal to negative 5. And solve for u in each case, and those are my 2 solutions then. By the way, you can kind of see how with absolute values, you will most likely get 2 solutions. So the question on the side will then be, in what scenario would you only have 1 solution with absolute value? But anyhow, going back to this, 3u is equal to 6 because I add 1 to both sides. So u is equal to 2, that's 1 solution. And for the other part, 3u is equal to negative 4. Be careful because you're adding 1 to both sides then. And so u would then be equal to negative 4/3. So those are my 2 solutions, and I'm going to go ahead and box them. And there you go. Okay. So then let's now move on to the next part of what we're saying then. So with relation to all of this right here, right, if you have to travel from one point to another, then there is a certain distance that needs to be covered, which can be expressed numerically. So this is kind of, again, looking at the idea of distance and absolute value. And here you can see in the picture below that if I want to go from one point to another, let's say from A to B or B to A, Mario is going to have to cover 6 inches in this case. It could be more. It could be like 10 inches. It could be like 20 feet or whatever distance it is. But whatever it is, there's a numerical value that you can always assign to it. So this then leads into our very, very first postulate. And a postulate, just to kind of like, give you an idea as to what it is, postulate is supposed to be basically a lemma or basically something that is very simple that you cannot prove. So kind of like the axioms that we were talking about in the last section, right? The commutative property or the associative property. So there's no proof to it, but we basically take these simple postulates and we use them to eventually build theorems that we actually need. So here we go. Here's the first postulate ever in this case. To every pair of different points corresponds a unique positive number. To every pair of different points corresponds a unique positive number. So what that means is that if you have a point, which we'll go ahead and call A, and it's located at -4 on the number line, and then you have another point B, which we'll say it's located on the 7 on the number line, there is a number that will correspond to the distance from A to B then. Okay, so there is a number that will correspond the distance to A to B, and that's that positive number that we're talking about. So here in this example, the question is then, what is that distance? What is the distance from -4 to 7 on the number line? Well, you can probably go by what we've been saying so far, right? One thing we can do is we can take the absolute value of -4 and then add it with the absolute value of 7, because then you can see that, oh, absolute value of 4 is the distance from -4 to 0, so that's going to be 4, plus the distance from 0 to 7 is then equal to 7, so the total is going to be 11. So visually, what I did was I solved for this part, which is equal to 4, and then I solved for this part, which is 7, so you can see that 4 plus 7 is equal to 11. Okay. Now, one last thing I need to mention is that there is a unique way that you can actually display this or write this. We would write in this case, AB is equal to 11. Which represent then the distance that we're looking for from point A to point B. Or you can even write it as BA. It doesn't really matter because the length from one to the other is the same as the other way around. So you can say AB or BA in this case, right? Because distance, again, is always positive. Now, there is another notation that you have to be careful about, which is the following. If you see AB and then you see a little line segment on top of that, that is the name of the segment. So, it's kind of like saying, Steve or Bob or George or something. It's just a name, so there is no numerical value that's assigned to it. So once again, if you see AB just as is, right next to each other, that is going to be assigned a numerical distance, which is going to be 11 in this case. But if you say AB with a bar on top of it, that's just the name of the segment that we'll use to identify the segment that we're looking for in geometry. So there's no numerical value that's assigned.